Hello everyone. Today I'm going to deliver another lecture on structural stability and determinacy. The lecture will contain, at first I will giving the definition of dosi, which is degree of statically indeterminacy, and then condition of structural stability, and condition of structurally indeterminate, and condition of structurally unstable. The unstable is contained in two sides, which is statically unstable, and another one geometrically unstable. Okay, and last one we will see the math example of degree of statically indeterminacy, which is called dosi. This is the important. Okay, so let's start the definition. The degree of statically indeterminacy-dosi is referred to the number of redundant or extra unknown force in a structure that cannot be determined solely, which is called only, and by statically equilibrium equation. As we know, statically equilibrium equation is summation of f of x, summation of f of x, and summation of f of y, and summation of moment. This is the statical equation. It indicates how many additional capacity equations are needed to solve in their internal forces. Okay, so these are completed. So let's see another example here. The term degree of statically indeterminacy is used to denote the difference between the available equation of statically equilibrium, as I have already mentioned, f of summation of f of x, f of y, and f of summation of moment, and the number of unknown forces. The structure is classified in statically unstable. When is stable? When dosi is less than 0, and statically determinate. When statically determinate, when dosi is equal to 0, and statically indeterminate, when dosi is greater than 1. And table 1 is shows here. We can see here the unknown forces. We can see here for 2D truss and 2D frame. We can see here the number of unknown member is given m, and 3m, and reaction r, and join to 2g and 3g, and internal hinge is not given here. As we know, the truss has no internal hinge, and reaction will be seen here, and dosi will be greater than 0, and we can calculate dosi stability. You can see here, and the dosi we can calculate here. We can see this is the equation, and this is the forces, and this is the equation. This is the forces, and another is equation. Okay, so let's see the condition of statically stability. Okay, here we can see in the stability is has a stability is required for structure to be able to carry the load as it is subjected to this. First one we can see here, the condition is structurally stable. A structure is statically stable and determined if the number of unknown forces equal to number of availability equation, which is summation f of x, f of y, f of z. So if we want to see here for 2 different, we know from 2D truss, f is a number of forces which is given m plus r. M means number of member. How many member? 1, 2, 3, 4, 5, 6, 7. This is the member 6. And reaction, and R is the reaction. How many reaction? We know 1, and this is the 2. So this will be 3, and this will be we have been 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Okay, this is the 7. This is the force. and E has how many joint is given, as we know truss as not any joint. If we can consider 2D frame, then joint will be 1 2 3 4 like this. And this is the equation we have been seen here, statically just stable. How can we say the stable? When force and equation are equal, then we can the member is stable. That means this force and this force is zero, then we can say the stable. Or we can see here how can say the stable. If this portion and this portion is zero, then we can see will be stable. If this calculation is zero, then will be stable, because these are the force option and these are the equation option, and this also force portion and this also this also force portion and this also equation portion. This also force portion and this also equation portion. So force, these are the minus, we can see these are the plus. So this portion and this portion is zero, then we can see this is the stable, as we have been seeing here. These are the stable. You can clearly here see, if we see the 2D frame here, 2D frame is we can see here member is 2m and reaction R joint 3R internal means, and reaction is given R is greater than 3s and dosi. So these are we don't need this, but rather than we will focus this portion. Okay, let's see the 2D frame. So okay, so dosi will be determined this. This is the equation 3m plus R, as we have been seen 2D frame, force 3m plus R, and equation we have been seen 3j plus s. We have been seen here 3j plus minus 3j plus minus s. This is the equation form. So if this calculation is zero, then we can see this stable. How these are the stable. On the other hand, we can see the 2D frame. If the force, that means this portion is greater than equation, that means this portion, then we can say this is the indeterminate. Okay, so if we say this portion force is less than equation or this portion, then we can say this is unstable. Okay, so let's see another. This is the condition is stable. So in this way, indeterminate, how we get a structure is statically I will say the indeterminate or stable if number of unknown forces, these are the number of unknown forces we have been seeing, these are the number of unknown forces F is greater than number of the variable equation. So available equation, so we know the equation is given here, or we can see here, we can calculate all together as the as we have been seeing. These are also, if the dosi is less than 0, then we can say unstable. And determinate, how we can say, if the dosi is 0, then determinate, and the dosi is equal to 0, then determinate. And dosi is greater than 0, then we can say indeterminate. So we can calculate both way, whichever we need it. So it will be depend on this value, or we can use this equation. I'm just calculating this equation, that's why I will clarify this equation, I will explain this equation. But you can use both. These are the taken from Professor Dr. Iftekhar Anand sir, Professor University of Asia Pacific, Dhaka, Bangladesh. Okay, so here another is given. We can see here the structure is unstable if number of unknown force is less than number of availability equation. So we can see here the unstable number of force, here is the number of force, we can using this equation, and less than equation, there is the equation, then we can say there is unstable. These are the this one. Okay, so we know the how structure can be unstable into two ways. So these are the, we know that these are the unstable, these are the stable, these are the indeterminate, these are the stable. So unstable we can find out two ways. is statically unstable and geometrically unstable. So we will see the how statically unstable is if f is greater than e, then unstable, as we have been seen. And geometrically how we'll get is all reaction is, if the all reaction is acting is parallelly, or all reaction is concurrent, then we will be unstable. We will see here in depthly this and this. Okay, so let's see here as an example. We can see here the unknown force, unknown equation is, we know the summation of f of x, f of y, and f of z is 3, and the unknown force is applied in 5. Then we can see force is greater than equation. So we can see not stable. This is the indeterminate. So dosi will be force minus equation, so it will be 2. Okay, so you can see here some we can see unstable, here the geometrically unstable, and the support is ruler, and if we load is applied, then the support will be go down. That's why this is the geometric unstable. If we see the one is ruler support and one is the hinge support is here, but there is a pin support or hinge in between two support, then if we apply in force, then it will be goes down this way. That's why this is also unstable. If we calculate here, we can see here the vertical reaction 1, and there is a for pin support f of x and f of y, there is a reaction 3, and we can equation 4, this will be also unstable. Okay, we can see here the statically indeterminate, how we'll see this is the figure, and this is also geometrically unstable. So let's see, here is some example we can see here. So I'm not giving here, I'm just giving here the two different. So let's see, I will find the 2D frame. So before we going to the 2D frame, we know the 2D frame, the equation is 2D frame. We are applying this equation. Okay, let's apply. So we can see for 2D frame, frame equal to 2m plus r for force, and for equation 2j plus h. So see how what is the m, what is the r. M is the number of member, how many member, and r is how many reaction, and j is a joint, and h is a hinge. Okay, let's see. For 2D frame, we can see number of unknown force 3m plus r, and number of equation 3j plus h. Okay, m is unknown number of member, r is a reaction, j is a joint, and h is a internal hinge. Okay, so let's see an example. This is an example. We can solve this example. Okay, so we can see here how many member, 10 member, 1 2 3 4 5 6 7 8 9 10. So these are the 10 member. How many reactions? 6. How this is the as this is the ruler, that's why 1. This is the pin, that's why 2, 1 x and x axis and y axis, and this is the fixed support, that's why 3. So 1 2 3 4 5 6, that's why the reaction is 6. So how many joints? So if we calculate the joint 9, I will get 1 2 3 4 5 6 7 8 9. So these are the 9 joints. And how many hinges? There is no hinge, there is no internal hinge. This is not hinge, this is internal hinge. So now we will calculate number of unknown force, as we have been calculating using this formula. So we are using this small formula, 3m plus r. So using 3m plus r, 3m is we know now 10, there is a 10, r is 6, we have been found 36. An equation we have been found 3j plus h, and j we have been known 9, we are putting 9 plus hinge, there is no internal hinge, that's why we have been 27. So if we have been seen force is greater than equation, so this is the indeterminate. So we have been seen here force is greater than equation, that is indeterminate. And we can use the dosi. How we'll calculate force minus equation, there is a 9 dosi, which is degree of structurally indeterminacy. Okay. These are the we can use here. On the other hand, we can use also this equation. If we use this equation, uh, then we can found here 36. This is the 36, and here will be 36. If we writing here 36, and minus will be 3j plus is how much? 27. Okay, so 27. So 27 and minus 36, it will be 9, maybe 9. So 9. So as 9, we've been seeing 9 is greater than 0, so we can see indeterminate. So you can use this equation also, but whichever you need, you can use all this in your way. Okay. So let's see another example. You can see here number of member is 5. How? 1, 2, 3, 4, 5, and reaction is 4. Is given pin support 2 and 2, 4, and joint. Now see the joint. Here is a 1. Sorry, 1. I'm just changing number, changing the color. This is 1, 2, 3, 4, 5, 6. This is the 6th joint, and hinge. How many hinge? This is the internal hinge. 2 internal is given. So as usual, we can use the force equation as we have been seen here, and putting this value and found here. And equation we can see 20. So force is less than 20, so it will be unstable. As we have been seen, this is the formula. So we have to memorize this. There is no other alternative way. Or we can use this as if we calculate here, then we have been found 19 minus 20. So 19 minus 20 will be minus 1. So minus 1 is less than 0. That's why it will be unstable. Okay, this will be unstable. So you can use this also formula, and after the calculation, then we will found minus 1. So minus 1 will compare this one. Minus 1 is less than 0, so it will be statically unstable. Okay. Let's see another. We can here member. We can see here how much member. 1, 2, 3, 4, 5, 6. There's a 6 member, and reaction is given 3. And joint how much? I'm just how much joint? 1, 2, 3, 4, 5, 6, 7. There's a 7 joint. And hinge, how much hinge is internal hinge? So we have been calculating here and found 21 is the force, and equation is 22. So 21 minus 22, so you can see is minus 1, or force is less than equation. So that's why unstable. Is minus 1 is less than 0, as we have been gone here and compare with this value. Then we will find the minus 1. Minus 1 is less than. That's why we will use the unstable. Okay, or we can use this formula also. So let's see another example. Here is a 3D frame. So now we are using this formula 3D frame. F equal to 6m plus r, and E equal to 6j into s. Or we can use 6j plus r minus 6 minus 8. These are the 3D frame. These are the 3D frame. As we have been seeing here, 3D frame is here. We can use 6m plus r. This is the force. What else? This is the force. 6m plus r, and 6j plus s. So we can see here minus 6j minus 6 is this. Okay. So let's see here. We have been we are seeing here on a many member. I'm just calculating as 39, 1, 2, 3, and 4, 5, 6, and 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 18, and in this way I'm just calculating calculating on and found 39. And reaction how much? We have been seeing all the fixed support. That's why three type of support will be each support. So we can see 1 2 3 4 5 6 into 3 3 6 into 28 8 18. And joint, how many joint? We have been calculating here 1 2 3. In this way we have been found 24 joint. And how much internal hinge? So there is no internal, so don't forget this will be internal hinge. So it will be calculating. We've been using force equation. So as we've been using 3D, that's where using force equation is, or you can use this part only 6m plus r, and found 252. An equation we know 6a plus is as usual 6a plus, or we can use another dash portion, and found 114. So 252 is greater than 114. So this is the indeterminate. Or if we use this formula, then how will be that will be 125 minus 252 minus 144. So I'm just using calculator. 252 minus 144. So this will be 108. So 108 is greater than 108. So greater than greater than 0. That's why we will using this condition. This is greater than 0, which is indeterminate. So in this way we can use this for frame 2D frame. We can use shortly 2D truss and 3D truss for this formula, but you have to memorize this formula by any means. Okay, let's see. We are already given the condition statically indeterminate. We are here giving the example of statically condition of statically stable, and condition of statically unstable, and condition of unstable geometry, statically and geometry. Now we are already seeing the math example of dosi. So it is going on. So let's see another example on 2D truss. I have been now I have been giving it showing the 2D frame and 3D frame. Now I will show the 2D truss and 3D truss. So let's see here 2D truss and 3D truss, some math example. Okay. Here is a we can see here is a equation, but we can use here 2D truss and 2D frame. Which one you want to take, it is depend on you. But all our calculation is okay. So there is no problem. So 2D truss and 3D truss. So equation will be 2D truss and 3D truss. Okay, let's see. Okay, so we've been known the unknown forces M equal to M plus R. So M plus R taking from here, and equation 2 into J, and J is a joint. So there is no hinge as a truss. So there is no hinge to J. So you have to memorize it. So as per we know, if the truss is stable, then M plus R to J, or F equal to E must be E. Or the truss is indeterminate if M plus R is greater than 12, or F greater than E. And truss will be unstable if M plus R less than 2J, or F minus C. So we have to these are the condition, or this condition. Okay, this condition. So let's see an example. Okay, so we've been seen here as usually the moment we have been force member. So member have been 13 member 1 2 3 4 5 6 7 8 9 10 11. Okay, and just how much it will be 13. Okay, if I mistake, then let me know. 1 2 3 4 5 6 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, these are the 13 member. And reaction how much? These are the 2 and these are the 1. These are the reaction 3. And joint how much? We have been known the 1, 2, 3, 4, 5, 6, 7, 8. There is 8 joint. There is no internal hinge, as we know. In truss there is no hinge, internal hinge. So we have to memorize them. And if we are now applying this force, this is the force equation and from 16 and using equation and 16. So this part, and if we use this equation to retruss 2m plus r, it will be 16 and 2j equal to 16. 2 into 6, as we know, j is given in 8. So if we using this m plus r, m is known here is 13 and r is 3. 13 into 3 into 16. So this portion will be 16 and minus 2 into j. How many j? J is 8. 2 into j, that means it will be 8 into 2 into 8 into 16. So 16 minus 16 will be 0. So we can see the condition is satisfied with 0 here. So 0 means determinate. Okay, so we can see this portion sorry, I'm sorry, it will be determinate. Okay, so in this way you can see here another example. We can using the member is 13, reaction is 3 and joint is 8, and found 16 into 26. So this is the we can see 16 into 16 is stable also. So here is another memory is, if the truss is form is triangle, that will be geometrical stable. So these are the memorizing talk, or this is important. If the truss is, there is no triangle form, then the truss will be unstable. Okay, so let's see 3D truss. As we have been at first we have been complete 2D frame, then 2D 3D frame, and now we are doing completing 2D truss. Now we are going to see the 3D frame. So this is the formula of 3D frame. So it's been seen. This is the 3D this is the 3D truss. So now we are going to see the 3D truss. This is the 3D truss, and this will be formula is, yeah. Okay, so as it is, we have been writing the formula f equal to 3m plus r, but equation will be 3j. So it will be 3j, or we can see minus 3j here. 3m plus m plus r into 3j. So we are using all this here. There is no internal hinge, so so there is no hinge. So we are calculating all this and found m plus r equal to m equal to 18, r equal to 6, and joint equal to 7. So m plus r equal to 24, and 3j as equal to j is 7 and 3j 21. So 24 minus 21, as we have been seeing, f is greater than e. So it will be indeterminate. So if we calculate in this way, as we have been from m plus r 24 and minus 3 is 21, which is plus 3. So plus 3 we have been putting here, plus 3 is greater than 0. So this will be indeterminate section. Okay, so this will be indeterminate. So let's see some exceptional. Here is the exceptional. You can see here m member is 4, 1, 2, 3, 4, and reaction also 4, and joint equal to 4. We have been seen 1, 2, 3, 4, and hinge equal to, there is 2 hinge. So f equal to, we have been found 16, and as 2D, there is a 2D frame, so you can use this formula, 3m plus r n equal to 3j plus h, and found 4t. So force is greater than equation, so it will be force is greater than what I will say, greater than so it will be indeterminate, as we know. But in this case, as we've been seeing, there is a exceptional case, so it will be geometrically unstable. So here is another, we can see here, as we've been found f greater than e, it should be determinate, but it will not determinate, but it will be unstable, because this is the exceptional case. That's why this is a geometrically unstable. You can see here, there is no dosi. Okay, so we've been seeing here another exceptional example. We've been seeing here, member is 2, r is 4, j equal to 3, h equal to 2. Member 2, how much? 1, 2, and reaction has been found 2 into 2 plus 2 into c, 4, and j equal to joint is 3, 1, 2, 3, and h equal to 1. Have been seen here. So f equal to 3m plus r equal to 10, and 3 plus j equal to 0. So as you know, 0 by 0 it will be determinate, but as this is the exceptional, that's it will be geometrically unstable. Okay, so here is another exceptional. See, member is 2, and reaction is 3. As we've been seeing, the this is not member. I'm just seeing here the force is concurrent, all the reaction is concurrent, then geometrically unstable. There is a two exceptional things. If the reaction is parallel, then it will be unstable. And another is all reaction is concurrent. That means if we you can see this reaction, and it will be going down here, and it will be here, and this also is going down here, and this also goes down here, and it will be here. So it will be, we can say this is the concurrent. That's why it will be unstable, geometrically unstable. Okay, if we calculate in here, you can see two member 1 and 2, and reaction has been acid 3 reaction, all other loss support. So as per our formula, 3m plus r will be found 9, and 3j plus h, as you can see 2 different, and 3j plus h, and found 9 minus 9, which is 0. So if we found 9 minus 0, then it will be, we know the stable, but this is the exceptional, that's why it will be unstable. Okay, so this lecture is in that. If you have any question, then let me know. I will try to answer your question. Thank you everyone. But before I'm leaving you, I'm just summarizing that we have to understand the stable, indeterminacy, and unstable. Unstable is two types, statically and geometrically. And then we have to memorize then how it is stable is occurred. These are the equation, and how will the indeterminate occurred by this condition, and unstable condition. So we have to must be memorize this condition, this equation, and this condition also. If we don't memorize them, then we will not find out anything. So we have to firstly memorize this for 2D truss, this equation, and 3D truss for this formula, not equation, this formula. For 2D frame, this formula, and 3D frame for this formula. And we have to, these are the condition we know, or we can use this condition also, whichever you need it, or which one is you like. So thank you everyone. If you have any question, let me know. Thank you everyone. Thank you.